This is lesson 6-5, solving a system of linear functions using the elimination method. So this is the second of our methods for solving a system of linear equations algebraically. I'll do the same thing as I did with the last lesson. I'll do a procedure on the left with an example on the right. So step one is to make sure that both functions are in standard form of a linear function, which is ax plus by equals c. You can see on the right-hand side that I have both in standard form already. The next is you want to pick a variable to eliminate, and it doesn't matter which one you pick. In this example, I'm going to choose x. Now, I could easily do it for y as well if I wanted to, but again, picking x or picking y, it does not matter. I'm going to pick x, and I'm going to make the coefficients match by multiplication. So, in other words, if this is equation number 1 and this is equation number 2, I'm taking a look at my x coefficients in both. I want to make these match. So for the top equation, since the bottom one has a 2, I'm going to multiply this entire equation by 2. Since the top one has a coefficient of 1, I'm going to multiply this whole equation by 1. Therefore, I'm going to end up with 2x plus 6y equals 13, or excuse me, not 13, but 26 on top. And on the bottom, 2x plus 1y equals 6. Next is to subtract the two equations. Now, for me, I like to put a line right here and put the subtraction sign on the outside. That reminds me that I need to subtract each time. So I start all the way over to the right. 26 minus 6 gives me 20. 6 minus 1 gives me 5. Leave the y alone. Leave all variables alone when you're adding and subtracting. Since I made the two coefficients match for x, that eliminates, hence why we call it the elimination method, the x variable. We are left with 5y equal to 20. Then I'm going to solve for my remaining variable. So I'm going to divide by 5 here, and I get y equal to 4. Then, just like we did with substitution, replace the value that you found in one of the equations to solve for the other variable. Again, doesn't matter which one you do, but always go back to an original. I'll take the top one. So x plus 3 times 4 equals 13. That's x plus 12 equals 13. Subtract 12 from both sides, and x equals 1. Again, we could check this by plugging in x and y in both of the equations to make sure that we have a satisfactory on both sides of the equation for both equations. Here's an example for you to try. Pause the video at this point to give yourself a chance to try it on your own. So the first thing I need to do is get these equations into standard form. The top equation gets into standard form by adding 2y to both sides. So my new equation is 7x plus 2y equal to 5. On the bottom equation, I'll add 2x to both sides. That'll give me 2x plus 3y equal to 16. Now, this time, I'll choose to eliminate y. So I know I'm going to multiply each of these equations. Since 3 is down here in the red equation, I'm going to multiply the top equation by 3. Since 2 is in the black equation, I'm going to multiply the red equation by 2. Hence, I end up with on top 21x plus 6y equals 15. And on the bottom, 4x plus 6y equals 32. Now, I'll subtract the equations. Keep my minus out here to remind me to subtract everything. I'll start with all the way over to the right. 15 minus 32 gives me a negative 17. The 6 y's will cancel each other out. 21x minus 4x is 17x. I'll divide by 17 on both sides to get x equal to negative 1. I now have x. I need to find y. I'll go back to one of my originals. The top one always works for me. So 7 times negative 1 equals 5 minus 2y. That's negative 7 equals 5 minus 2y. I'll subtract 5 from both sides to get negative 12 equal to negative 2y. Divide by negative 2. And 6 is equal to y. Again, you can check by plugging in x and y into both equations. Here's a word problem example. Pause the video at this point to write down the word problem example. So as shown, we're going to have two variables for this particular word problem. For student ticket and adult ticket. I let A be the adult ticket sold and S be the student ticket sold. The theater club sold a total of 101 tickets to the play. Total would mean to add. That's where I get A plus S equal to 101. The total ticket sales were $164. A student ticket costs $1 and an adult ticket costs $2.50. So $2.50 times A plus $1 times S gives me the $1.64. Now, you could solve this with either method, elimination or substitution. Since we're in the elimination purposes, I will solve it with elimination. I'm going to eliminate A by multiplying the top by 2.50 and the bottom by 1. This gives me 2.50A plus 2.50S equal to 252.50. Then, since I multiplied this by 1, nothing changes. Now, I'm going to subtract my equations. And I'm eliminating A. And now I have negative 1.5S equal to 164 minus the 250. When I do that in my calculator, I get negative 88.50. Dividing both sides by negative 1.5, S will be equal to 59. At this point, since this is the number of student tickets that I need, I can stop at this point and do my conclusion statement. Therefore, there were 59 student tickets sold. To be on the safe side, you should be plugging back in, solving for A, and making sure that A and S work for both equations. If you have any issues in any portion of this lesson, please make sure you are emailing me or consulting me in class.